And with that, I'm delighted to be joined and to have Genevieve here to talk about retail solutions and how we're working globally with retail with MongoDB. So thank you. Round of applause for Genevieve.
Thank you, Nick. Thank you. Hello, everyone. Can everyone hear me okay? Yes. Okay, brilliant. Thanks for coming down. And I know it was a little bit difficult to find, perhaps, from the keynote room. So well done for finding your way down here. My name's Genevieve Broadhead, and I'm part of MongoDB's Industry Solutions team. So what is our Industry Solutions team? Well, we know that we're just a database technology. On top of that, you have to build a whole nother architecture, applications, things to bring your business forward. And the reason that you're here today isn't just to learn about technology. It's actually to learn how can you bring it into your business, create applications that can help you drive success, go towards your digital initiatives, etc. So what the function of our team is, and this org, which is part of MongoDB's product org, is really to help you understand how to use MongoDB, how to use our features, our functionality, our database, to build applications for your businesses. I run our global retail team, which is one of MongoDB's largest industries here in EMEA, but also across the world. And so what's the current wave? What's the current technology that everyone is talking about? Well, of course, generative AI. So perhaps, we heard a little bit about that in the keynote this morning. Actually, it took a while to even get to it. It wasn't the first slide, so that's a little bit of a change from last year, which is quite nice. But generative AI is the hot topic. We talked about it abstractly last year. This year, we're actually seeing our customers use our technology to build applications that are in production and actually bringing real value to their businesses, to their customers, to their internal teams. And so what I want to talk to you about today is Retrieval-Augmented Generation to supercharge retail applications. For those of you that were in the keynote, you might have noticed that the Novo Nordisk guys made a really good point. They were training their AI applications on their internal knowledge base so that they could rely on the answers. I think he said something like, we're not allowed to be wrong in our industry. And that's such a good point. Retail, you have a little bit more room for error when you're recommending products. It's not as, life or death, perhaps, as in pharmaceutical research. But it's still very important if you want to be, protecting your bottom line, getting conversion, winning the trust of your customers, that the content you're producing, the products you're recommending are actually really of use to them. So, we're in this kind of golden age with Gen AI at the moment. And I want to share with you today, what we're seeing in the retail industry. Always interesting to look at because, we notice, especially actually for our... Oh, is that what that noise is? So sorry, guys. Can you hear me now? Can you hear me? Oh, okay, very loud. So retail is a great place to look, I always think, because they're very fast moving. It's a competitive landscape and there's no option to just sit back and wait. If your competitor is first to market on something, they're going to capture that bit of market share. So even if you don't work in a retailer today or in a retail technology company, I think it's a great space to look for inspiration on what these architectures actually do and how they work. So overall, where have we seen the value from generative AI for our customers? So after a long year of experimentation, after a lot of uptake in Atlas Vector Search and looking across all of the industries we've been working in, all of the use cases are really boiling down to these three fundamental areas. So number one, it's no surprise, assistance and automation. So it became immediately obvious when OpenAI came out that the way we work with these conversational chatbots was fundamentally going to change, that suddenly we're actually going to have an informative and nice to talk to experience founded in real data from our organizations so we can actually get good help and not like a few years ago when you're just saying, I want to speak to an agent, I want to speak to an agent. The second piece is all around reasoning and analysis. So within your organizations, you have a vast amount of data about how your organization runs. But bringing that data together and getting actionable insight and answers from it is very difficult, especially if you're not a technical person. If you don't know how to query, if you're reliant on a dashboard that's being delivered by a developer who has a million other things to do, and you've got to wait a month for the next request or the next business insight to come out. The applications we're seeing people build with generative AI in that business intelligence space are absolutely excellent because they allow the use of natural language, both from a query perspective but also a response perspective, to open up and democratize that data across the organization. The Novo Nordisk use case was a great example of this. And then the last one, of course, is application development. Again, in the keynote, we saw a great example of how we're using, AI and generative AI to speed up development. And that's really creating a shift in your ability to move faster, develop applications faster, and bring out new features to market much faster than ever before. So we've seen a lot of customers be very successful. We've seen a lot of POCs. We've seen a lot of things maybe not be as successful, or, experiments that didn't actually bring in business value. But what we've seen is, and what we're beginning to look at is, where are the use cases and where are the value areas in each industry where we're seeing our customers actually have a lot of success. And, if you're thinking about building a use case, please come to our industry teams, come to our solution architects, ask us. We probably have experience looking at it. So, let's hone in on retail. So, as I said, some of our retailers were the first ones to jump on board when we launched Atlas Vector Search, as they have been when we launch other, features within our application stack. And so some of the use cases that we're talking about today are not like pie in the sky ideas. They're actually ones that we've seen retailers across the world build on MongoDB and bring into production. So what are some of these use cases? So first of all, better customer experiences. So, let's say I go into a large goods store, I buy a fridge, I take it home. Do I then have to go into an application and manually fill in all of my customer data so I can have a warranty? Or because the retailer actually has my customer data, it can automatically be populated into a system. When I reach out or go back onto the website of the customer, if I'm going into support, does it know that I just ordered that and that I probably need some help from a PDF manual or something, a question about it? When I go onto the e-commerce website, is it going to suggest that I buy a fridge again, which is what we often see? Or does it know that I've actually just bought a fridge? I'm probably doing it in my kitchen. I might want to buy an oven or a toaster or look at the tiles, etc., etc. These kind of hyper-personalization and recommendation engines are something that retailers have been building for years. But with the advancement of generative AI, and especially with vectorization of data, it's just bringing it to the next level. And that's always an area of investment when it comes to retail and retail technology. Now, it's not only in the customer-facing applications, it's also in really streamlining operations to the next level. So whether it's improving business efficiency through actually being able to get data from those systems that you need to do your jobs, or in the application development space, speeding up your coding, et cetera, et cetera. But also in the back end, in the supply chain, if you think of an order tracking or supply chain tracking application, there's a lot of different systems within your organization who have data there. Being able to really quickly and easily gather that data together, ask a natural language question of where is this shipment? Is it on a boat? Is it in a warehouse? Is it going directly to the customer, etc., can give you really immediate insight, and being able to kind of understand that data in real time in an easy way is really powerful. And also being able to potentially go the step further and start making automated suggestions. So, for example, if you know a shipment is coming into warehouse B on this day, then perhaps you want to put on more staff to look after that, and based on the rest of the data how much staff you need in the warehouse to process that within a certain amount of time, for example. So why aren't all retailers doing this? Why aren't all of your applications utilizing generative AI across the whole stack when we've seen this business benefit? Well, what we've seen, and this is a great survey that Workday did last year, is that 98% of CEOs say that they want to embrace AI, they want to bring it into their applications, but only 4% say that their data is accessible enough to do so. Actually, 59% say that their data is siloed at the moment. Now, siloed data isn't like a unique proposition. If many of your MongoDB customers, perhaps you've got a MongoDB operational data layer, you're trying to bring data together for different systems. But where it's become more complicated is that now we're not just talking about that operational transactional data. Now we're also talking about the insights you need for AI, the data you need for AI and generative AI, unstructured data as well, and also the additional data types needed to feed the AI algorithms. So in this case, we're also talking about vectors now. If we look at the classical approach to data management for AI and application intelligence, typically, data and AI are having like completely separate infrastructures. You've got your operational hot data in a database, so that could be MongoDB, it could be something else, where you're running all your transactions through. That's your main e-commerce store, etc. Then, after a day, you're pushing that data into a data warehouse or maybe, some kind of big analytics tool. But it's an older view of the world. You're not also taking into consideration that real-time data. You've got an operational and an analytical view in two different worlds. Then what happened last year when vectorization came along, when everyone got excited about generative AI, rather than bringing the worlds together, actually a whole new world popped up. This kind of standalone vector database sitting in between on its own. And so we end up in this world where you're bringing data around from point A to point B to point C, and it's very difficult to actually get, to build an architecture on top of that is leveraging your data in a useful way without adding so much operational complexity. And the other piece of it is, of course, the data model that you're working with. So I don't know how many of you recognize this diagram. It's one we've been using at MongoDB for quite a long time, but it always resonates to me because like in this kind of entity-based model, your data is really siloed by design. So even when you're trying to bring it together, if the 20, 30 years that you've been working with those relational paradigms, then bringing in COTS products, then bringing in proprietary data stores, then you've got your analytical data, and now you've got your business services layer. It's incredibly complicated to bring that data together in a way that really makes sense to power your applications. And when we look at AI, I always think, and I was actually with a customer yesterday here in London, and they said, data is the fundamental requirement for AI. If you put, garbage in, she said, you get garbage out. It's all about providing, reliable information, up-to-date information to your AI system so that you're getting out answers that not only reflect reality, but also reflect things in real time and are up-to-date. So we had a really good example last year when we were working in the airline industry with an airline out in Asia, where they wanted to create an algorithm that was going to upsell tickets on their airplanes. So trying to get people from economy class up to business class. They took out the data, they curated it, they trained the algorithm, they put it live, and when we put it live, there was a 66% uptick in the sales of those business class seats. They were delighted, we were all happy, we all went home. Then they came back to us 2 months later and said, it's down to 29% uptick. What happened? Like nothing changed, we didn't change anything, like what's gone wrong? Well, that was the problem, they hadn't changed anything. They hadn't retrained the model on the new data. The model was trained on their old analytical data, and the smart customers on the front end, as I'm sure you're aware from your own websites, customers are smart these days. They change their behavior really fast when they realize that there's AI running there. They're going to change their behavior, and so how you're changing your models, how you're doing things, how you're presenting different price estimates has to change in line to that. This idea of just training your AI models and just running your AI on that analytical or older world data and not taking into consideration the hot recent data just doesn't work in these days. You're not going to get the same kind of results or the same kind of answers. And of course, that's incredibly complicated when you've got a data estate that looks like this, where it's all in different shapes and formats and you can't bring it together. So MongoDB's kind of mission statement, and this might be something you've kind of heard over the years, is to make data kind of stunningly easy to work with. That used to be the one from like 4 years ago. Or unleashing your developer capability. Well, that stayed our mission statement. And, as we've understood that like the applications you're developing don't only have to do their job, but they also have to be using these AI algorithms, that, we talk about all data being easy to work with, not just the operational data, but also that AI and vector data that you need to build these kind of retrieval-augmented generation architectures or for interacting with large language models. So how many of you tried to build a generative AI application? We've tried to like simplify it here in terms of like these 3 layers of generative AI. The bottom layer is kind of, hardware, compute. How many of you follow, NVIDIA, for example? Down there is the models themselves, the platforms you need to run it.
The middle layer is really where MongoDB comes in. So the tooling and data that base the infrastructure to be able to actually use these models, the inputs to those AI algorithms. And then the top layer there is where you come in as developers, as architects, building those applications on top that can really provide value to your customers. So this is the piece we want to talk about at MongoDB, and where we're really positioning ourselves to be able to try and help you when you're looking to build retail-augmented generation applications. The interesting thing when you look, and the retail industry in particular, 80% of real-world data is unstructured. That makes it incredibly hard to bring together into one place. So, of course, a flexible document model is a really good way to think about it, to look at it. So, if we think, for example, of something as simple as, or as simple perhaps as a product recommendation, think of all of the data you actually need and the formats it's in. So product descriptions, perhaps you've got that in, an off-the-shelf PIM system, or you've got it maybe in MongoDB, who knows. Then you've got customer digital touchpoint data. That might be time series data coming in, click streams from the web interface. It also might be voice recordings of the time I called into customer care to complain I couldn't find the icebox on my fridge. It also might be any time I've tweeted or reached out via Facebook or reached out via WhatsApp, trying to get that data in as well and merge it together with potentially transactional data from when I was in store and I bought something physically and it came through the POS in XML format. It's a lot of different data to bring together, and more of it is becoming unstructured, and trying to make sense out of that unstructured data is, really what we're trying to see generative AI be able to do. So great example here is, customer manuals, which are in PDFs, which are in physical copies. It used to be very difficult to get that information out. So what we're trying to, help our customers be able to build is this generative AI data layer. Not just an operational data layer that you're able to build powerful applications on, but to bring it the step further where you're able to build these generative AI architectures and you have all of the capabilities you need within the platform to be able to do that. So that's taking in the operational data from your systems, bringing it into the customer world, taking in those analytical insights through integrations, and then bringing in this new unstructured data. That also might be video, it might be audio, it might even be images. These days, a lot of people are doing, image search, trying to understand if I see a picture of an outfit on a celebrity, take a picture of it, put it into Google, now I know where to buy that kind of thing. We're even seeing this go into the audio world, where in-store assistants in the fashion industry, instead of just looking up an item, are able to actually talk into their mobile device, their store mobile device, and say, do we have any other items of this type, or is this certain item being able to be shown in a different color, so they're not kind of painstakingly typing it out as the customer is standing before them. So what's emerged over the last year is that big part of this generative AI stack is not just that data that's coming in from your applications, but also vector embeddings to be used with the large language models themselves. And so what we've done is we've brought into our product, as you heard today in the keynote, and for those of you who are already using it, is that vector capability into our core database. So the whole idea is for you to bring all of your data, the product image, description, the feedback from the customer, the audio data, etc., into one place. Instead of having a single operational database and then a separate database, vector database, bringing it all together so you can look at it together just in one place. So let's say I'm adding in a new image, it's much easier to automate because I don't have to then manage the movement of data between those two things. Let's say I do a new ad campaign and I have some new photos I want to put them in. I'm just inserting them once. I'm not inserting it, making it sure it goes somewhere else, et cetera, et cetera. And for your developers who are working in your teams, or perhaps you yourselves, it's much easier because it's one query language, one technology, one thing to operate, one thing to maintain going forward. So unified into one simple API. So why did we do this? Well, it was to make building generative applications really easy for you guys, but Of course, you know, in the back of our heads, we're still aware that a lot of those large language model challenges, you know, didn't go away. You still have to worry about data security and privacy, ethical use, and, you know, how are you going to actually enforce ethical guidelines onto that data usage? You know, what if you're using a black box model where you actually can't predict or understand why a certain answer is being given to a certain person? You know, perhaps it's really inconsistent and unsuited for business needs. If I go in and ask a certain question one day, is it going to give me the same answer the next day? If I ask a question, is it going to give me the same answer as someone else? And can I explain why that's happening actually within my data? And also things from hallucinations. Can I be sure that, or how can I make sure that the data that I'm presenting, the answers that I'm presenting, are actually based in fact, or actually based in truth? So what is the solution to these? Oh, first of all, I've got some little examples of where it goes wrong. And you'll have seen loads of examples of this. You know, over the last couple of years, these are some I pulled from TechCrunch. So Google's Gemini, for example, was race swapping historical politicians came to light. Another one in Air Canada, where they'd automated an AI chatbot for customers, and the AI chatbot started hallucinating and started making up policies for returns and refunds. So customers were going on and saying, my flight was cancelled, can I get a refund? It said, yes, no problem, Mr. Customer. And Air Canada actually had to spend millions as a result of what the chatbot had been saying to the customers in refunds. Another one maybe a little bit closer to home, DPD, the package company, you know, had trained its chatbot to be polite, but you could, you know, there's always people going in and messing around with these. So the minute you went in and said, don't worry about politeness, you know, don't worry, I don't mind, it started swearing at customers. So how do you avoid this, you know? Or how, if you're very happy with your GenAI application and you put it live, you don't want your CTO turning around to you the next day and being like, I just saw this on Twitter, what the hell have you done? So Retrieval-Augmented Generation is a great methodology for building generative AI applications within your company that you can actually trust the output of. So it's the process of optimizing the output of a large language model by referencing the internal, secure, authoritative knowledge. Again, this is what Novo Nordisk were saying. The model is not being trained on outside data, it's being trained on its internal data that it knows and that is reliable, that's true. It really extends the capabilities of those large language models with the enterprise's internal knowledge without having to kind of constantly retrain the model because you're working with operational data. You know, who knows the most about your customers, your products, your buying patterns? Well, you know, it's probably you. It's probably stuck in that enterprise data warehouse somewhere. It's stuck in your operational data. It's just about leveraging the knowledge that you have on your customers and bringing it to light. So the key thing with Retrieval-Augmented Generation is that it's all based around kind of vectorization of data. So what are vectors? It's a numeric representation of data and its related context. So you'll take your product, let's say if we're in the product world, your product image, its description, its sizes, its colors, everything else about it, where you might wear it, throw it into a Gen AI model, get back a vector representation, which will look at it from a number of different contexts. So what you're getting back is this array of a string of numbers that it can then compare to each other in kind of 3D space. How closely related are these two items? So, like, you know, if you think about it, like, one of the things that is really important is the ability to bring that vector data in with your operational data. And I won't go through this in too much detail, but just hammering home the point that, like, if you're trying to build a Gen AI application, you need, you know, great query abilities for your operational data. You need the ability to store the vector data. You need it to be able to scale, etc. So where will you begin? I've got a few actual kind of, you know, proper examples now that we've talked a bit at a high level. And I think semantic search is one of the key use cases we're seeing retailers get a lot of value out of. And not just, I feel like when people say search, and especially search retail, they think of the e-commerce portal 100%. It's it's not just e-commerce when I'm thinking of semantic search. It's also in your like supplier onboarding, your internal teams, your kind of, you know, allocation teams who are trying to like match products together in a certain assortment and fashion, for example. Lots of different teams. So, but of course the examples that are easier to understand are the e-commerce ones. So vector search, you know, can answer these types of questions. Semantic search is all about understanding what is the true desire of the customer, aside from just those words. So, you know, what outfit should I wear to a wedding in Spain? What are the recipe ideas for dinner tonight, if I'm vegan, perhaps? What should I buy my girlfriend for Valentine's Day, etc.? How do you answer these questions with normal full-text search? Well, the answer is you can't. How does it happen, and how does semantic search work? Well, as I described earlier, it's matching together those vectorizations in space to understand how close are two items to each other. And I've got a great example here of the difference. So let's say I'm looking for a dress to wear. On the left-hand side here, or on the right-hand side, you'll see I've searched for blue floral summer dress in this e-commerce search. Now, unless that search term in its exactness is kind of in the product description, in the product title, I'm going to get no results back. Now, if you're working in retail, you'll say, yes, but I've got advanced search. I've been doing this for a long time. I've got all my synonyms programmed in. Blue equals azul, dress equals gown, etc., etc. But let's think of a retailer where you're adding a lot of products over time very fast, and you don't want to manually be doing these things. You want to be doing it in a more adaptive way, and that's looking at it from, you know, contexts and perspectives that you actually haven't even thought of, because it's also taking into account the image information. With vector search, now, the great thing with Mongo, again, is that you don't need a separate database. It's just an extra field in your product document, an array of numbers with the embeddings. Now it's comparing the vectorization of the query, the blue floral summer dress, with that linen gown that's in my product catalog, looking at the difference between the query and the item in my catalog, you know, but the difference between them. And you're almost never going to, one of the great things here is you're not going to get a null result answer. It's always going to give you the thing that is closest. You know, null results is probably one of the worst things to get in an e-commerce experience. So what you're doing is relying not just on the text, but also all of the information that you have there. And you can do this without adding a lot of complexity at all, just by adding in one more field to your document. The AI model is doing all of the heavy lifting when it comes to actually bringing that data and kind of coming to the conclusion yourself. So if we look at the architecture of that kind of solution and what it would take to build it. So let's say on day one, you're going to put all of your product data into your MongoDB Atlas collection. What you do then is, you know, trigger off a kind of a change stream or something else into the embedding platform of your choice. In this example, I put in Databricks. It could be anything. It could be Vertex AI. It could be Anthropic. Whatever your model hosting platform of choice is. You know, we've made that decision at MongoDB to be really agnostic because, you know, the race is still ongoing in terms of which of these technologies is going to win out, which of these hosting platforms, who has the best model for each thing. When they've got the embedding, the AI is doing the hard work to figure out what are the complex relationships between the products, between the customers, etc., and popping that back into your database, not as like a whole separate collection, just as an extra field in each of those documents so you can understand it. Then, when the person, in this example, they're on a little mobile phone on your website trying to understand what they're looking for, when they're saying, I want that blue floral linen dress or something else, that query ticks off into the same model. A vectorized embedding of it is coming back, and those two vector embeddings are compared to get the closest similarity matching to really show you something that is as close as it can be physically. And we've actually got a great example of this. If you go to our product booth in the booth area later on, we've got a great example. We've built a little e-commerce application and what happens when you turn like vector search on and off in terms of the difference of results. It's all about just automating the understanding instead of manually having to understand the difference between the products. So use case number 2. And this is one where retailers were traditionally doing a lot of manual work, is like personalized content creation, again, using Retrieval-Augmented Generation. So like, think about how much information you have that you're using for personalization. And like, personalization is a funny one, and like product recommendation is a funny one, because you can use a product first result or you can use a customer first result. With a customer first result, we're really looking at like across all of your transaction history, all of your engagements, what are the kind of price points, what are the brands you usually shop at, what time of day are you usually shopping at, et cetera, et cetera. What's the best way to outreach to that customer in that space? The old way of doing this was by customer segmentation. Jen is an Irish girl in her 30s. Let's offer her this, this item, regardless of who I am. I saw a great example with a customer I was with recently, where she pulled up her mobile app and it was offering her nappies and beer. And she was like, I don't drink and I don't have a baby. Like, segmentation of this sort just doesn't work. And with generative AI, we don't have to be doing segmentation, because we don't have to rely on teams of copywriters to be manually doing each one of these reach outs. What we can be doing is using Retrieval-Augmented Generation. So, without kind of vector search, without bringing your own data into the platform, if you put in, I want a newsletter recommending one of my products to everyone, you're going to get a very generic result out that's not personalized to, each of your customers. Whereas if you bring in the information you know about your customers, you're going to get a really personalized result out. So this is an anonymized example we have from one of our kind of biggest retail customers in Europe, who have built an AI RAG application on MongoDB with vectorized data to give out generative AI newsletters personalized to every single customer. Basically, they can click a button and say, I want for each one of my thousands of customers a personalized newsletter, something that would have been completely impossible or just too, operationally or, cost-wise manually prohibitive to do. They can do it for each customer. They can also do it for like localization. So let's say there's a football match in a certain area, etc. What they've done is vectorize the data that they have living in MongoDB. So you can see here, that's the wish list data, it's the loyalty data, the purchase history, customer behavior, etc. You could also be putting in other data that you've gathered. So it could be like trends or buying patterns within the region. Then all they have to do from a marketing perspective is put in a prompt. Send me out a personalized newsletter to every single one of my customers recommending one product based on things they bought before. And then when I get into my inbox, instead of getting something very generic, offering something that I probably don't want to buy, what they're getting instead is something like this. For the past 3 years, you've been... I can't remember what I wrote. Replace several of your kitchen appliances, including a Smeg fridge and a kettle. Customers like you are primarily interested in, this brand of this kettle, et cetera, et cetera. I feel known. It's something I'm much more likely to buy. I'm much more likely not to unsubscribe from that message. Potentially I'm going to really up my conversion. These days customers, they don't want to be reached out to a lot. And so you need to be really making the most of that. This doesn't go just for newsletters. If you think of any e-commerce store, half of what you're seeing is banners, it's images, it's this summer season, barbecue weather is here, etc. People are manually doing all of that writing, all of that content creation. Being able to personalize it, localize it with generative AI is a really good way to meet your customers. Another example, and this takes it a step further. What if it's just not just your images? What if it's also your products? We have customers who are looking at building applications to actually automate in the same way product design and imagery. So, great example of a fast fashion retailer creating new t-shirt designs, that their data in MongoDB, so the t-shirt styles, the colors, the recent trends, the graphics they have available, the types of t-shirts, etc. they have available, and it's automatically generating suggestions of what the next graphic t-shirt could look like. Then, when that graphic t-shirt is made, they can automatically supplement the images they have with models of a different size or a different color, or in different locations to make it easier to go to market. This type of content, not just the product, but the product imagery, the product description, really the types of ways of doing this are endless. We've got some great examples in like the marketplace space of customers who are, taking on a lot of suppliers. If you think about like food delivery, etc., and like restaurants, that if they put in a picture, if they put in an image, it will automatically suggest attributes. Really speeds up supplier onboarding, but it also makes the customer much easier, make it easier for the customer to find exactly what they're looking for. So one last example, and of course it's kind of probably the least surprising example, I left it for last. But yeah, chatbots and virtual assistants. Like, I've actually even seen a move from people saying chatbots to really saying like conversational bots, because you're no longer just asking a question and expecting like a direct outcome. You're actually expecting to have kind of like a pleasant experience these days. Like, our tolerance for these has really gone up as we have, or as the technology has gotten better over the last few years. So this is a nice stat I got from Cisco, actually, that 75% of customers want a personal interaction, but not necessarily with humans. That actually 64% expect real-time assistance, but they don't care as much anymore if it's talking to you personally, or they know they're actually talking to a person at the other end of that chatbot, or if it's automated, as long as they're getting the right answers. And like, we're even seeing this in stores. So like, great example is a beauty company we work with who have created an app for their beauty advisors in store, where the customer is asking the beauty advisor has a certain amount of knowledge themselves, but they can also interact with the Gen AI system to automate and kind of come up with some of those new ideas for them. What does this look like? Well, here's an example of a RAG-based retail architecture for this kind of customer chatbot. You'll see up here at the start, at number 1, we're bringing in the data sources from all across the organization. This could be product images, product visuals, PDF manuals, etc. It could be your order transaction history. Then you're using an embedding model to vectorize that data and store it back into MongoDB alongside your operational data. Why is it great to have both of those things together? Well, because I might be asking for a recommendation, that example earlier where I was like, what should I wear to a summer wedding? But I also might want to know the returns policy, something that has a direct answer. I might also want to know, where is my order at this point of time? When's it going to be delivered? That might be a direct answer as well that lives in the operational data rather than the vector data. When I make a customer query, when I log on to that chatbot, and that could be me or it could be the person that I called in customer support, what it's going to do is embed that query in embeddings, compare the embeddings of the query to what I have in my knowledge database, knowledge from all across the organization, and then create an answer. Not just an answer, but running it through a large language model to give an answer that is formatted in a way that makes the user believe that, that it's nice to read, nice to interact with, conversational. So, the ability for us to do this has really changed, and like the ability to do it at scale has really changed. And we're seeing some really great examples now of like interactive chatbots that are taking information from all across the organization and serving customers in different ways. If you guys are more on the development side and you're like frequent users of MongoDB docs, this is a great example. Within our docs interface, you can now ask, natural language questions of our documentation and get answers if you don't want to try to figure out how to browse through it. So really the question is like, where are you beginning when it comes to retrieval-augmented generation, and like how to unlock some of that value when it comes to AI. So, personalized product recommendations, as we've talked about, is a huge one. Dynamic content generation for e-commerce, conversational shopping assistants. We're seeing automated product descriptions. So people just putting in a picture of the product and it actually automating not only the product description, also the attributes to make it easy to look through, etc. Visual search optimization, if I'm actually looking for something by uploading a picture myself and getting an answer back. Again, if you go to our product booth, the guys have done an excellent demo for actually a car insurance use case, where if you upload a picture of like a damaged car, this is for the internal staff within the insurer, they can, automatically with that image understand what is kind of like the average claim size of that, what kind of damage has been done to the car based on what it's seen. So we've got some really good examples of this, and we've also got like a physical book of like different industry use cases that's available there just for free if you want to go up, although they do run out quite quickly. So head up there. Customer sentiment analysis is a great one. So if you think about taking in all of that customer data from Facebook, from Twitter, from any other kind of like engagement platform, and really being able to understand like, what are customers saying about your product? What are customers saying about your company? How can you react in real time to that instead of getting a report a month later and not being very happy about it? Interactive virtual shopping is a great one, especially in the beauty space, where we're seeing like great applications where you can like try on beauty products, see what it looks like in your skin. And localized marketing campaigns is a great one, that you can be really reactive to what is happening in a certain geography at a specific time, be it a football match, Taylor Swift concert, something else. So thanks for your time today, and I hope it's given you a bit of an insight into the types of applications that our customers are building, with MongoDB to help with generative AI and like power the business in a different way.
Brilliant, thank you. We've got some time for questions before we end. So any questions for Genevieve? Pop your hat out, there we go.
So you spoke a lot about personalizing recommendations, interactions. How does that weave in with users now not wanting to share as much information with websites, with analytics tools? So does that hinder this process in any way, or how does that sort of affect it?
It's a really good question, because like one of the things with like super advanced AI is that the customer wants to feel known, but they don't want to feel like so watched that you're being a little bit too creepy. So yeah, it's a really good question, and that's all about fine-tuning your models to like pick the kind of degree of accuracy that you're comfortable with. There's a wider piece. Is that working? Yeah. There's a wider piece as well about like, as we're getting less data from like website tracking, etc., trying to push people towards loyalty programs so you can actually capture more data on them without them kind of like, feeling it. And a lot of that is about value. If you're providing value back to them, then they don't mind, if you're actually, if they're able to go in store and get like a really great recommendation based on their usage, then they don't mind. It's when you're kind of feeling like you're very watched without getting a good output that you get a negative reaction from customers. But yeah, another thing to think about.
I have a question about vector embedding. So I'm assuming every document in the database is embedded into its own vector, right? How does it find the relationship between the documents when it creates the embedding? For example, if I have different collection about customer information, so one of them could be price history, one of them could be the metadata of the client, etc. Is it capturing the correlation between those documents when it creates the embedding?
Yeah, great question. When I talk about kind of comparison of vectors within a certain database, within a certain collection, what it's doing is using our vector search indexing capability. So within MongoDB, when you fire a query in, you can use a number of different queries. We've obviously got our normal database querying, normal database indexing. So, indexing on a certain field within your document, be it like the name, the price, description, whatever. We've also got the full text, which is coming through Lucene. And then now we've also got the vector search indexing. And so depending on what query you put in, the chatbots are a great example where, it will see what the query is. Is there a direct answer? If I'm looking for order ID XXY, and it can just use, normal database query to match on that field, or was it a full text search query when it wants to use a search index, or should it actually be using the vector index to compare the vector embeddings? That's really the beauty we've brought into the platform, is the simplicity of just having one API and using a multitude of different indexes within the platform to compare the answers.
Brilliant. Thank you, Genevieve. Before you all leave, please ensure that you've completed your surveys for the sessions. As I say, it's great to have the feedback for our speakers. Enjoy the rest of today, and just a final round of applause for Genevieve. Thank you.